Go ahead. Thank you. Thank you very
Good
much.
day to one and all present. I, Supriya, on behalf of the Institute of Analytics USA, welcome you all to the meetup today, hosted by Institute of Analytics USA, which is the training arm of CRM portals, which is the big data intelligence consulting company incorporated in the USA. IOA USA, as it is popularly known, offers training programs leading to a certificate or a diploma in big data engineering and data science that includes machine learning and artificial intelligence. For more details, you are welcome to visit our website www.instituteofanalytics.com. IOA has been hosting regular meetups on emerging areas of advanced data science and big data technologies. Today, we have the founder and MD of the Institute for Advanced Data Science, Dr. Netra Sambamurthy, who will be addressing on the topic Time Series Analysis and Forecasting, a 10-week course, part 1. Before handing over to Dr. Netra Sambamurthy, I would like to request each one of you to kindly send in your personal, in case you're working your professional position and from where you're coming from, which part of the world you're coming from. You could send it in the chat so that we can read it out to you.
Yeah, so you don't have to introduce yourself by voice. If you like to do it, great. Otherwise, just type in the where you are joining from, what's your interest, just two things. That's good enough. What if you can say a background also, that would be nice. Whatever. Okay, go ahead, please. Just type where you are joining from, what's your interest in data science. Those two is good enough. When you type, your name automatically comes in. Please do while I start presenting it. Go ahead.
Starting from Durga, from the chat, I'm starting from the order.
You like to hear your voice, nonetheless, it's okay. Durga is joining from New Jersey, looking for a job in data science. Wonderful, welcome. So what do you do, Durga? Just you can say, your sentence there too. Okay. What do you do currently? I mean, you're looking for it for a job. What kind of background you have? Okay. All right. Next, please. You type. It is better because you don't have to wait. Welcome, Durga. Okay. We don't have to wait. I would like to read out who you are, where you're joining from, what's your background, okay, and what's your interest in data science. Go ahead. Let's start because really today is the technical day. We kind of introduced last time you have something, okay. So last time, basically, I introduced the topic, references, HTML book, latest form, which I will be using mostly, is this one. And GitHub or the key book, okay, and the author. I have mentioned that also. Is it flicking by any chance? Can you tell me what's going on? It looks like my feedback is flicking. No?
Yes, yes, it's flicking.
Okay, now it's okay, stable now. Okay, so today let's start with the quick review of the series data, and then we will go into the packages, essential packages. I'm going to talk to you. It's really a rich session today, and you will give me input at the end whether it is rich or not. There's a lot of things we have to talk so that we can do analysis in the next week onwards. Okay, so take a look at these pictures. Okay, what we're saying is that the series could be any one of these forms. This is just going up and down. That means there is a trend that is basically flat trend. This one, but there is always errors around the trend. Okay, that's called noise, and there's the trend. It's a flat trend. Okay, non-seasonal constant trend. Now here you can see constant trend, but there is seasonal effects. Every few months ups are going, downs are coming, and so on. Okay. Very interesting, right? And then if you come into the third one, it's a constant trend, but also, as the time goes, the effect of the seasonality is multiplicative. That means higher and higher values are happening at the high end and lower end. Okay, so you can call it as the constant trend. Okay, the other one is constant trend with the additive seasonality. The third one is constant trend with multiplicative seasonality. Now let's expand that one. So now it is not constant trend, flat, but it's increasing, right? So increasing trend, and then increasing trend with the additive seasonality, increasing trend with multiplicative seasonality. So the difference between additive and multiplicative is that the seasonality is constantly of the same effect. Okay, it is not increasing significantly as we go over time. That is what is happening here. That is what is called the multiplicative seasonality. So here it's non-linear. It's not just a constant upward, but it's also non-linear. That means initially it is slowly increasing trend, but then it is increasing higher and higher and higher. Okay, so this is upward exponential trend. Okay, but still non-seasonal. But here you can see seasonality is coming, upward trend with seasonality and upward trend with multiplicative seasonality. And now we have here what is called the third order. This is the second order. This is in fact first order. This is the second order. This is the third order polynomial trend. Again, no seasonality. Here you can see seasonality is coming. That means remember, every few months or every few weeks, seasonality doesn't mean it has to be only monthly. It can be even weekly also. Okay, it can be even weekly also. So here third order polynomial trend, which means it has two derivatives, positive two derivatives which are not non-zero. The third derivative will also be non-zero, but the fourth will be zero. Okay, that's what third degree polynomial means. Up to three derivatives will be non-zero, and here it is multiplicative seasonality as we go further from here to here. It is third order polynomial trend with multiplicative seasonality. Actually, I would like to see this graph. I borrowed this graph. It should be higher and higher and higher going like this. Okay, there is something that I need to correct, borrowed from somewhere else. Okay, so in essence, these are the systematic parts: level, trend, seasonal parts. Non-systematic part is noise. Okay, these are the really three things, right? Whether it is level or trending up or down, and seasonal patterns. But there is also cyclical pattern, which is more than the seasonality. See, seasonality repeats in a cycle. Every cycle it will be repeating. That is seasonality. But if the repetition is not every cycle, but something other than yearly, 2 years, 3 years, and it repeats. Usually, economic cycles are there, which are usually around 3 to 5 years. But it doesn't mean that it exactly comes on 3 years or 5 years or 6 years. But it will always happen. Remember this: if it didn't happen around 5 to 6 years, if it didn't happen, it is going to happen. Be ready for that. That's how economists predict certain things. Okay, so now second part I have come. We need this package called tidyverse. Okay, and it is only giving you the basis for data management, but it is still not time series data. So the tidyverse has multiple packages put together, and it is coming under the term called packages for our data, or packages for the course or for data science. Okay, that's Hadley Wickham has written a book along with somebody else, and Hadley Wickham is a superstar who has created a lot of good things in R. He's kind of amazing, his contributions to R. Okay, so the tidyverse, they realize that these are the essential packages. ggplot2, which helps for graphics. Tibble is a new version of data frame. Characters are characters, and you can view the data better. And it has some other things also, more consistent definitions, and you can, it won't misbehave, behave differently depending upon context and so on. So that is table. It's really a table data. That means rows are experimental units, columns are variables. That's as simple as that. Okay, and no, that is coming for the tidy R. Tidy R is really the rows are columns. I'm sorry, rows are samples, columns are attributes. Table is more about basically about having a nicely behaving data frame. And if you ask me a question of what is data frame, all those things, we teach this foundations for R foundations and Python foundations for data science. We do teach that in our diploma course. But today I want to review these things, quickly. Okay. So ggplot2, Tibble, tidyr, which really makes sure that the data are brought back to the structured form where rows are samples or experimental values and columns are attributes or variables. Okay, and also per, which provides consistent set of tools for working with functions and vectors. You will see. Here is an example. Okay, it's an interesting example. In one line, you can do multiple regression models. The regression model is miles per gallon, as a function of weight, and then that is done multiple because the data is empty cars is split by the cylinder variable K456. Okay, so there are multiple data sets, actually 468 for the data set we have, not 5 but 468. So the split is made on the basis of the cylinders. That's what it is, and each of the cylinders we build a model here. You see this piping in one line. Not only piping is used, but also the vectorization is used very effectively here. So we take that vector miles per gallon as a function of weight, and then we do the model, we map the model, and then summarize the model, and then take only the R-square values from each of the model. That's what this one is. So you can see that the 4 cylinders are really fitting better compared to 6-cylinder and 8-cylinder cars, for miles per gallon as a function of weight. Okay, so it provides that facility. It's quick vectorized computations, very powerful, fast vectorized computations. dplyr is again works with data frame, but this one is I think there is a typo there. I'll have to go back and correct that. It's not really about. dplyr is a very nice summarization. It's a kind of SQL, SQL simplified SQL, if you want to call it. Okay, simplified SQL, and its version also works on databases. That's called dbplyr. Okay, it's very powerful. I love this dplyr and dbplyr. Okay, so we will use this. So remember this. The reason why I'm bringing all these things today is that we will use. There are 2 parts to time series analysis. One is the data management of it, wrangling of it. That's what the packages coming from tidyverse will be useful. And the other part is TS, the equivalent of tsibble, which is tsibble, that is time series able. Okay, table time series able. So the time series able version is a extension of tibble package, which we will use it for time series purposes. That is working on time series type properties, data structure, and so on. That's what I want to tell you today, that the tsibble, which we will see quickly, is really about time series relevant tibble data structure. Okay, so I have a few slides about introducing quick introduction for R. I'm not going to run through those things. Tibble, read read dot. Usually people use read dot CSV, but use read underscore CSV. Again, it's part of the read R. I didn't probably talk about this one. It's an alternative to read dot CSV. It's much faster and it can read zip files directly. So there is some introduction about the R here, quick R here. I will not go through all of them, but maybe some few things I will walk around and explain it to you. So you might have a question: what happens if I'm going to use Tibble? What am I supposed to do when the packages use data frame? There are some older packages and they use data frame. What are we supposed to do? So there is a command called as data frame. Okay, so use that as data frame. It will convert your whatever the tibble you have, it will convert into a data frame, and then you can use the older packages. So remember all those things. So the dplyr, I said that I want to give you some quick introduction there. dplyr, these are the keywords that are used. Selection, you can do columns. If you want to select columns, use the select. If you want to use the rows, if you want to select rows, use filter. That's what this means. Okay. And if you want to order the rows, then arrange. That means it's really sorting. Sort function is called arrange. Sort, S-O-R-T function. Okay. Um, oh, welcome. I think you introduced yourself. Thank you very much. Welcome. Rename is, of course, sometimes you want rename, you want to rename variables for convenience, and there is a function called rename under dplyr. And mutate is really basically you are computing or transforming or creating new variables out of the other variable that you have in the data frame or table. Okay. And then, of course, you want to summarize, generate summary statistics of different variables in the data frame, possibly within strata, that means groups. You can do summarize. And finally, the pipe operator. It's part of dplyr. You can use that. It's also part of another package, available. Okay, so we'll see that too. But the key part here is this is where the data wrangling happens here. Quite a bit of data wrangling happens here. So we will be using it also in our exposition and usage of time series analysis. Okay. So here is an example. For example, there is a data that I read, and it is called the Chicago. Let me see whether I have it here. Chicago. Let me see here. And some of this yesterday just to make sure that Chicago year. Yeah, so I can run it here. So compressed file problem, no such file. I have to see what is the get working directory, current working directory, right? Working directory is in documents, so that's not where I have that data. That's the reason why it is, okay? And so I got to say set working directory. So I'm going to put, I rebooted the system, so I have to do all these things now because of that. That's fine. We go to empty cars or not here. Not here, so maybe J. Okay, here it is, Chicago RDS. So it should be the place, okay? Copy address as text. Hopefully. Okay, let's see now. I don't want data because it is not. All right. So that is what I read. And from there on, you can see I can use these commands. Basically, I'm subsetting Chicago data starts with D. That means, these are the second part is about the variables you are selecting. Very simple. That's why dplyr is very powerful and I like it. Or you can even say, basically here you can see Chicago names, Chicago 1, 2, 3. The first three names here, that is city name, city, and data dictionary is about this daily temperature, and some other variable here. You can go to Chicago. Let me see what it is. Chicago pollution data set, right? So this is the data set that I was looking at. Okay, for example, I just want to make sure that you understand where I'm getting all this data and what it is about. So read full report, apply for see health Chicago, read through. Okay, data pack, indicator values. So let me see. This is about data pack. So this is where you will get, for example, the various variable names, okay? So, and their definitions. So, but let's just go through some basics here about R, how R handles. You will see something very interesting here. You know, R can read all kinds of data. So this one is really, RDS is an Amazon data storage name, you know, file extension. So think about all these things, you know. R has many ways of reading data, whether it is CSV, tab, text, RDS, or you know, XLS, and so on. You all know that. So let's go back to. So here I'm explaining all these things. Now, if you want to select only all the variables, city. So okay, let's just find out what are the names we got here, right? Name Chicago. So these are the variables that we got: city, TMPD, DPTP, date, all those things. Okay, and I'm saying only from here to here. That's what the colon means here. Okay, so that's what the colon means here. And I can also select all the variables, but drop certain variable. Then I use minus this vector notation. Okay, then it will select all the variables other than these three variables. So you can do the select. That's my point. That is, if you want to select the columns. If you want to select the rows, then you have to use the filter. Okay, and here we are saying the variable, the key variable is there, and then we are using this data set name and the variable condition. PM25T mean 2 greater than 30. So what we are saying is this variable PM25T mean 2 greater than whatever that number was, right? 30. So it will filter all the data. So if let's just quickly do that one maybe, so that you get a little bit of confidence in terms of, oh, okay, the code really works, right? So I have to be very careful here because shic.f, okay, that's only storage name. Okay, so let's put that one. First of all, let's find out dimension of Chicago so that you know that it is reducing the size. 6,940 rows, 8 columns. Now let us do this one. Okay, so and it is storing, it is filtering Chicago data set where PM25 T mean 2 is greater than 30, right? So if you do that, let's just find out dimension of Chic F. Okay, it's only 194 records. That's the point I'm saying, right? So you can also view still Chic F. All right. So if you look at this one, PM25 T minus 2, right? 1 second. Just make it bigger in the feedback system. PM25 mean T mean 2 is everything is greater than 30. You can see. Okay. This is 30.3, just passed, and everything is above 30. That's what we have done here. Okay. And it's for all the columns. It returns all the columns, but make sure that the rows are defined only by greater than PM25T mean 2 greater than 30. So you have selection by the column, selection by the row. Beautiful, right? And then you can arrange it. I said, right? Remember that? You can arrange it. So arranges for just to sort the data. So here is, for example, let's just do this one. Arrange in descending order of date, right? That's what desks mean. DESC, right? DESC, descending order. So you can do that. It's just so these are all part of. I'm going to call it as okay, maybe. So if you do that, if you view CHIC2, remember this is the earlier one is F, right? I'm going to close it. I don't need to keep too many of these things. The purpose here is to get some control, understanding about how to manage the data, and then use your time series, key packages. Remember, that's where I'm going, right? So what are the key things I use for data management? Under data science construct, okay, that is the tidyverse, which has essential packages for data management and data analysis, tidyverse. Basically on the data management side, remember, and then visualization. And then once I use that and modify and manage the data, I move it to time series, package so that I can handle the time index very well. So I'm coming to that also. Just hang in there. Okay. So here I said, everything should be, it should be descending order of date. Just make sure whether that it is a descending order of date or not. You see this one? It starts with December 31st, 2005, and it is decreasing. I mean, it is going back in time. You see this one, right? It's all going back in time. It's all 2005, now October 8, and so on. So, okay. So I just want to make sure that you are convinced. That's all right. And then you can rename. So that's an example here. That's what you're seeing here. Rename. Okay. These are all essential tools you need. Mutate is again transform variable, create new variables. You remember that? Okay. So here is, for example, taking the data set. Always it's very simple, right? First, it's a functional notation. That means left parenthesis and right parenthesis. Okay. And use first part is the dataset name, and then you do whatever the things you want to do. Here it is transformation I'm doing. Remember this PM25D trend. Okay, PM25D trend is PM25 minus mean of the PM25. So you are taking the mean value. That is what D trend is all about. Okay, and what are we going to do with the NA values? You have to remove them. Okay, that's all we are saying here. So this is a mutate is used to transform or create new variables. Remember that. Okay, transmute is another function. Similar sounding function. The thing is, it will do the same as mutate, but then drops all non-transformed variable. In one which you can do it in 2 steps, but if you want to do it in 1 step, transmute. Okay, that's what you have to use. And of course, the next one I want to talk to you is about group by. So the group by is, let me see, a nice example I want to talk to you about. So define the data, using the group by. I'm going to create a new data under the name years. Okay, that's what this one example. Okay, and same data set Chicago, and I'm going to group by the year. That's what it says, because if you look at it has multiple year data, right? So let's say unique. Unique will tell you. So for example, dimension Chicago, I want to recall again. It is 6,940 records, right? So if I want to see length, how many different distinct years are there, right? Chicago dollar year, right? Chicago dollar. No, date. That's what I should use. Unique. So that means I'm looking for unique dates. That may be problematic also, because it will give every day is unique, right? So what we are saying here is, let's put that command directly. I don't have to go roundabout. Let's just use the command here and see what that year's data set is telling. I think I need to run this first before. Oh, that's the reason. Okay. So there is something called, I want to talk to you about the POSIX. Okay, I call it as POSIX. So the date is, we need to convert that into a particular internal reference for dates. It is called POSIX LT, and you have to say as. Okay, as dot POSIX LT, POSIX uppercase, and then the particular variable, the date variable. Then it converts it into R internal. And then from that you pick up year. Okay, from that you pick up year, and then you add 1900 to that. Okay, so that because if you do this way, it will give me only 1 year. Let's see what I'm hear me out what I'm saying. So let me do this first, what this is about, so that you understand why I'm doing that. Okay, so if I do this one, I will just put head. Okay, because otherwise it will print 6,000 lines. So what am I doing here? I take the, I need to do, I still have to do some more things here, right? So Chicago So I'm taking the date from Chicago. See, I teach all these things. We teach all these things in R foundation, R and Python foundations for data science in our course. I'm kind of giving a quick review. So if you don't know, don't worry about it. You can pick it up yourself if you want, or you can attend our courses also. That's fine. So Chicago dollar dot it really picks up the date from Chicago, because you remember date is here, right? This is the date available from Chicago data set, isn't it? So let me go up a little bit. Yes. So the names is date is available in Chicago. I pick up that one, and then I convert it into a POS6. Okay. And then I pick up year only from that. Okay. And then I'm printing only the head, because there is going to be 6,490 values otherwise. Is everybody good on this one? So it says the first few values, the 6 values are 87, 1987. So that's the reason why I want to consider as a, as a, as a 19,000, I'm sorry, 1987, I want that instead of 87. So the way the data is stored is like this. So I want to consider that and add this. That's why this 90 is, 1900 is being added here, okay? And that, I know that's the transformation I'm making using the mutate, right? So for the data set Chicago. So that's what this one is. I just added that into the Chicago data set, and that is called year, okay? And rename is also happening here. We are renaming these values here as year. Year is not there before, remember that, okay? Only date is there. So if I do that now, okay, that's fine. View Chicago now, let's do what happens. So here, see, we added that, the year here, 1977, coming from this date, okay? So the way it is passed out is, using the mutate function, but let's see what I want to do. I want to group that by year now, okay? Group by year, okay. And I call that years, okay? Now, let's see if you see view here. No, let me just put the dimension years. It says again 6,940. So it's grouped by years in this case. Let me see what is the what is that we want to achieve. Look at this one. I'm looking for a good example. So among the notes I have, so let's do this. Ungrouping this mean maximum years. Continued from the previous slide, okay? So let us take that, now that I group the data by, in this, years data set, and if you look at that, it has 9 variables now, okay? View years, just see quickly, view years, okay? City, TMPD, DPTP, date, TM25 main. No, we don't have these values. Right now it is not available because these are missing. So remember that we will sometimes we will remove or we will use it in include that in the computations. So what we are saying, where we are going is now. Let's do this one. Summarize. I hope you can read that, or maybe I can make it here. Let's see. Summarize. So we are using the data set years, and then I am renaming something. I'm doing what is that, the mean, and then I'm taking multiple columns here, mean, and then the maximum values, okay, for the variable O3T mean to, and then median values. So I'm taking all these complex computations here. Slides I had to miss about 20 minutes last time, and I would like to. Okay, that's fine. We'll talk about that. Yeah, we can. We are posting. We will post the video. We have this week. It is more technical, and the long video will be posted. Okay, I will do that, and it will carry these slides also. And I will post this video. Slides also. So we are taking the multiple complex computations here. There is one mean value for a particular variable. For another variable, I'm doing the maximum. For another variable, I'm doing the median. I'm doing very complex computation where I'm removing the NAs. All these things are done using the summarize command. Summarize is part of the dplyr. Remember that. Okay, it's again, these are all data wrangling. So why this the maximum and median is are happening by the years. Okay, so that's where the group by is coming into play. So now let's just run this one. Okay, and let's run this one. Okay, something is. Oh, I can't do just like that. So you have to be very careful about it. Copy and paste, I can't do it because different versions have it. So different applications have different ways of doing it. So storing the data, copy of the commands. Let's see, now we have this. I want to make it as one line so that there are no unnecessary characters there. Okay. Now let us see this. Okay, that occurred in group 1. So error problem is summarize column PM25. So why is that? Column PM25 is a problem. Let's see, PM25 is not there right now. Okay, that's why it is. Okay, so I'm going to take that out. PM25, O3, T mean 2 is there. So that variable is not there. That's what it says. Okay, so let's take out this particular one, PM25. Just do only 2 parts. I'm just going to show as an example, isn't it? So let's do that. All right. So you can see that the data is now summarized by the years. That's my point. Okay. And for that, you need that first statement to be group by and then followed by summarization. Beautiful summarization, complex summarization, complex data wrangling that we have here. Okay, so let's continue. There's a lot to do. So summarize, which I showed that one. So and then the piping, of course, I showed that earlier also. Piping means you can continuously take the input, take the output of previous statement, move it to the next command, take its output to next statement, and go on systematically combining the outputs so that you don't make any errors. So otherwise, if you store it, recall it, there are possibly you might end up in errors. That is avoided in the piping commands. And here is a great example. Another example I have here, but I already showed you under the per package, you can do that also, and per gives you powerful function. They make the functional programming more powerful, extending the functional programming in a very consistent way for very powerful vectorization of commands. Okay, for vectorizing the objects. The beauty of R is that the vectorized, in my opinion, is the vectorized computations and it's functional programming. Functional means within parentheses, left parent, right parent, you do all kinds of things. Okay, everything is within that kind of parentheses, unless selection. Selection is square parameter. Okay, square parentheses. So as I said, we talk about all these things. I want to move on to time series data now. It's already 9:40. We're going to hit 9:40. So what do I do with this? That's where I'm going now. Okay. There are also other packages. What I'm going to do is now I will do these things into 2 parts. Whatever I have done with the basic data management, data wrangling part of it, I will post it as recorded just now, whatever we did, or I might re-record it and post it for you. But there is also another collection of packages. This is what are essential for time series analysis, right? So this is about T-Sybil, time seriesable package provides a data frame for tidy temporal data with wrangling tool. So whatever I showed you just now is about cross-section data. And in order to transfer that for time series type data, we have T-Sybil package. So please remember this one. It's very powerful. I like it. And the author here, FPP3 package author, Rob Hinban, actually contributed to that. Very good package. And the other part of teachable is that teachable data. This is already converted, time series converted data, right? Ready for you to do some simple analysis and learning as a learning package, right? So this provides the data sets available for, in time series format for you, and we are going to go over those data sets. And this is again about the time series version of tibble package. Okay, it adapts the tidy's data principles, and then index is a variable with inherent ordering from past to present. See, this is where I want to get your attention. In a time series data, think about it. What are the things you need? You need a time index. Okay, and Table systematically identifies what is the time index. That's why it is a time series based table data set. Okay, I think it keeps flicking. I don't know why. Okay. And then key is a set of variables. Again, I'm going to go here, select this. Key is a set of variables that defines observational units over time. So in other words, quarter one, quarter two, let's say 1987, quarter one, quarter two, quarter three, quarter four, 1988, quarter one, quarter two, quarter three, quarter four. But then, each of these time index has one time series data value, right? One time series data value. But those values might be changing based on factors in between. They are called the keys. Okay, the keys are the factors in between that says why for the same year quarter there are multiple observations. That's what the keys are about. Index is about the time. Each observation should be uniquely identified by index and key. That's why every observation will be uniquely identified by index and key. See, time series data doesn't mean that for one time index point there will be only one value. Okay, because if it is a complex data set and we have more factors, varying the values of the time series values for each of the time index, then you need the keys. Okay, so these are the three things I will talk about: index, keys, and the values. Okay, the observational unit or observational value. Okay, and I said, teachable data has the sample data sets for you to explore and work. And the the package feast is a package feature extraction and statistics for time series. Again, you need feature extraction and statistical methods for time series, and that's given by feast package. Fable tools refers to core tools for packages in the Fable framework. Fable framework refers to forecasting models. Okay, it's very simple, very fast, quick works you can do with Fable package. So we will see that as an example. Here is an example. Take a look at this one. Okay. Again, remember, Fable is some commonly used univariate, multivariate time series forecasting models are captured in Fable. Okay. And here is library Fable, and I'm taking data from teachable data. Okay. And that has many data sets, including UK lung deaths. And I'm piping that, take that data set, move it to, into this form, construct models. Use, what kind of model it is. It is called ETS model, exponential time series modeling. So whenever you have exponential time series data, remember that. I don't know why sometimes it flicks. I can see it in the feedback. Whenever you have time series data, remember, and if exponential model, you will use one of the ways to solve the problem is using log transformation. Okay, remember that. And then you model that. Okay, model that, and then you take the output and the name forecast. That's what it says. Okay, you take the outputs and then do the forecast. Next, so there are three things happening here. You take the data set coming from teachable data, and that is stored data already converted into your time series type data, which means it has a time index. What is the time index? You can see already here, the month. Okay, month is the year, month is the time index. That's combined factor is the time index, and then the keys are, number of deaths is here. No, there is no key here. Okay, there is no time index. Yeah, okay, there is no key here. So you may have a key, you may not have a key. If you don't have a key, that means every time index has one observation. If you have keys, then the changes in the keys will yield multiple values, multiple time series values for the same time index. So if you run this one, you can run, just very easy. If you do that, you're saying call in the Fable package, won't be a problem. No extra characters. And then call in the table package, use the data set from this. And what is the data set you're going to say? UK lungs data set, and take that and model it, as an exponential time series model, so that it's a log transmission of the M deaths, and then forecast it. That's exactly what we're saying. So it is not there. Let's see what is going on. Library. I think Teachable is already there. Let's see Teachable data. Okay, so UK lung deaths. So maybe it is taken off from the data set. Okay, it should be coming from there. UK lungs data set. Maybe it is given differently. So how do I know that? I can check it out. So go there. So let's check it out here. Yeah, we don't have the data set here. Okay. So we can use some other data set, but then no, I don't want to enter into other data sets because every data set has a different type of keys and so on. You have to know all those details. So I'm going to go into the definition of time series data for that reason. Okay. So we'll come back to that, and maybe we can do an example there. So package anytime really helps you to convert the times, whether you have it in integer form, character form, numeric form. You can use anytime to modify that into a different type of into a time data, whether it is character form, integer form, numeric form. You can convert it, and also you can even if it is in some kind of an ordered structure. Okay, you can use any time to convert it into date time parsing. So you need that for time series data. That's why I bring that here. And these are all some small things. But distributional, I think I mentioned that we discussed in our class, in the statistics class, various distribution. So typically DPQR for every distribution, whether it is normal, student, chi-square, F, all those things, there is something called DPQR. I don't know why I'm getting this flickering. Okay, DPQR distribution, that means density, probability, distribution, which is a cumulative, quantile, and random sample selection. That's what DPQR. This DPQR refers to. Okay, density values. Okay, density values, probability distribution value, quantile, and R. That is R refers to random sample selection. Okay, so we kind of saw all these things. Let's quickly do some. I'm going to do now. I'm going to do now some time series, teachable data wrangling. We have talked about exposure to certain important packages that would be useful for data wrangling with our objects. And then once you do that, you want to convert them into time series data and then work with them. For that, you need index, keys, and values. So here is, I'm going to take the, so here is, teachable data, tourism. It has a tourism data set. Let's see. Teachable data. Oh, really? Okay. So, oh, it is probably, it is in the F. Okay. It is an FPP3, FPP3 package. Okay. And I'm going to do both library FPP3 and FPP2. So now let us see UK lungs. Still not there. Okay. So what about teachable data? What about this tourism, right? We talked about tourism data is available now. Okay. So let's do this. So when I do the tourism data, this is what I will get. Okay. There. This is what I want. So if I call in the tourism data, it is already in time series label, teachable object. It is already a time series object. That means what are the three things you will have? One is index. The second one is keys. Third one is values. So that's what you have here. Index is this one, quarter. Okay. Index is quarter. region, state, and purpose, they all come together as keys. Remember that, okay? Keys could be multidimensional keys. That means, what does that mean? You will have multiple values, for the same quarter, for changing values of these keys, okay? For changing values of these keys. And what are the value Adelaide, that is the region, state, and purpose. This is the Australian data. So region is Adelaide, state is SA, business purpose is business. This is the tourism data. So number of trips that is recorded in that data set for this time period is, for these purposes, is 135. That's what this means, okay? And this has this teachable data. Remember that this has a table type, viewing, because it is coming from table, right? It's table type viewing. There are 24,000. This is what, when you ask for the data, it will print, the top 10 observation. That is one of the beautiful things. Simplifying action of table, which is transferred to teachable, okay? There are 24,320 observations are there, and then there are 5 columns are there. That is, this quarter, region, state, purpose, and trips. 5 columns, okay? And what is the, so it shows 10 values here, and then it shows how many more rows are there. This is the standard representation of table. So it is being used here in T-Symbol. Only thing is that it is a time series data. So this is called the measure. This is what our time series data is. These are the keys, and this is the index, okay? So it can also allow multiple time series data. Right now what we are seeing is only one time series. Remember, okay? It could be multiple time series values, measurements with multiple keys. It contains an index, measured variables, and key variables. This is the structure of time series data. Okay, and this is what we will leverage to do the visualization and analysis. Okay, it works with tidyverse functions. And what are those tidyverse functions? You know that a collection of tables. I said ggplot2 is very easy. There is also a function called autoplot that becomes part of this, and it figures out based on the index, based on the measured variable, based on the keys defined as part of the data structure. It figures out how to plot. That is what is called the autoplot. So all these things are made possible, easier to do because of the teachable package. So it's a very powerful, very useful, well constructed. And there are other things in tidyverse, right? So I showed you, recall all those things. If you want, I have to go back here, tidyverse. So all these packages work perfectly well. dplayer works with that, per works with that, reader works with that, tidyr works with that, tibble, ggplot works with that. That is why these things are all consistently put together. Tsymbol works with the tidyverse type functions. Okay, all these packages. Let me go back there. I hope you got some very key information here so far, so that you can kind of go back and use these things. So let's take so you might wonder, okay, look, Tsymbol data has already constructed for us. Okay, how am I going to create Tsymbol data, right? So here's the example. It's basically, it's the vector notation here. Year is between 2012 to 2016 for observations, not 5 observations, 12, 13, 14, 15, 16, right? 5 observation, and this is the y values. So I'm defining year and y. This is the time series values. I'm going to define it, and this is the year. That's the time index. So I'm going to define index as year. That's very simple way of defining Tsymbol data. Now it has all the functionality. It can use autoplot. It can use other things, other functionalities which are similar to the Tibble packages and Tibble functions. Okay. So when you just call for that my data, it says it is a Tsymbol. Okay. 5 rows are there, and this is the structure of Tibble. Remember that. No, it will give the variable name. It will tell you what that format is, and then it will print the top 10 values. That's what the Tibble does always. Okay, so that's how you define it. So here is another example. You might define a Tibble first, and then you can convert it into as Tsymbol. So this is another way. You can either way you can do that. The answer is same. Okay, you can construct a Tibble, or in other words, you already have a Tibble data. You can convert it as Tsymbol, as underscore Tsymbol data, but then you have to define index. If You just need only index here because you don't have keys here. If you have keys, then you have to define the keys also. So take the tibble data, and tibble data is what? It is data frame, regular data frame, but with a modern outlook. Certain functions that you can, certain properties you can expect to behave consistently. That's what the tibble is. It is same as data frame. Okay? So you know how to go from data frame to tibble to as tibble. Very, very important, right? So that converts the data into time series format. Of course, when you want to convert it, you need to have the index, the keys. Remember that. And now you can do all kinds of work with the teachable data, and including auto plot, which is very, very powerful, which figures out what is the time index which is going to be on the horizontal axis and what is the vertical axis, which is the time value, and the observational value. So we kind of said that. So the other thing is now, the index, time index could be of any type. It could be annual, quarterly, monthly, weekly, daily, sub-daily. You will see what they mean sub-daily, right? It's date, time, hours, and minutes, and so on. And you use these functions to figure out, the time index, the frequency, and so on. Okay. So let's see that example here. So I'm reading a present population data here, and there are, again, it's a tibble data right now, and we have to convert that as tibble. Okay, remember that. And this is, it has date, it has state, gender, legal status, indigenous or not, and then the number of cases, right? And remember that 3072, and then you do some, you do the piping, all these things, you can do all those things anyway, because it is only tibble data right now. That's fine. And then you can do the using because of the tidyverse combinations. You are selecting all variables except the date. That's what this means. Remember that I taught you all these things momentarily. And then after you do that, you are converting that into teachable data, which means you have to give an index and you have to give a collection of variables that constitutes a key. And this is the index is quarter. Okay, index is quarter. That is what 2005, quarter 1, quarter 2, quarter 3. That's the index. And then keys are state, gender, legal, indigenous status or not. Now it has become teachable. Now you can plot using auto plot quickly. You can plot many ways. There are GG plot version of it. I will talk to you about that. Subplots you can do, and then you can do by seasonal. GG season is there. We can do. We'll see some examples quickly there. I'm going to go there now because of time constraint. I'm going to go to the, so this is about passenger data. Let's see whether I have that. Present population. So these are production out. Okay, so let's do one more example because I need to show you what I have here right now. Okay, maybe it is somewhere down there. GG sub-series beer production. Electricity is there, season. So let's go to the electricity. Okay, so electricity say data is also there. Okay, big electricity, or something like that. You can see that here. So teachable data with electricity, right? You see this one? That's what this data is about. Okay, so it has the date, time, right? It's teachable data, so it has an index, right? So that's what your time index will be. This. Remember that. In fact, it has every 30 minutes data. I don't know whether you are able to see this. This is a sub series actually, right? So it's a date hourly. Every half an hour they have the data. That, it's about electricity demand. Okay, this many units are demanded. This is the temperature at the time. On this, if you just want the date alone, is this year, and then is it a holiday or not? So this is your teachable data for demand for electricity. So let's just quickly see some examples of what we can see some series, in terms of the visualization. Okay, let's see. Not this one. I went to a wrong page. Okay, so let's go to the. I'm going to go to the specific example. U.S. unemployment. Okay, so here it is. So there are different plots are available quickly for you, and this is one of them. GG season. So it figures out, because it's a yearly data, you can figure it out. The macro level is yearly, but subplots is also available. That is time wise, day wise, and the hourly wise. So we are going to see all these things. The beauty of this simple GG season. So it's not just an ordinary time series data. We are only plotting January, February up to December for every year. You see this one? Now you know where the changes are happening very easily, right? Look at this one, right? So it just says GG season, total cost, labels both, okay? Y is $1 million, and the title is seasonal plot. This is about drugs, okay? So let's see whether sub-series, this is about drugs again. As production, GG season, beer, tourism. This is the electricity data, right? We talked about. Look at this one. Just simply GG season demand, okay? The data set is, we are only printing, we take that, VIC electric demand, and it prints beautifully Q1, Q2, Q3 by the year, because the season here means again one year over year is seasonal, okay, but then years are the dates are given to you, not just months here. So every little detail is given here. But the most important thing is you can see the pings are here very high. For some reason, there is a demand, very high demand in 2014. So we have to look at what is the reason there, right? And there is a less demand here, for example, overall less demand here, but pink is only less demand here, which is year 2014, very significantly low here, significantly higher. These things matter, why this is happening and how do we adjust that and all those things. Further analysis about ARIMA modeling, all those things will explain these things, but I just want to get your attention. So here is again season, but then here now weekly data, okay? Every week your representation is weekly. Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Your representation is here quarterly, but the whole data is printed. Here also the whole data is printed here. But you are keeping weeks as a separate, weekdays as a separating time point for us to visualize, okay? Separating time point for us to visualize. And if you want, you can even construct it for 24-hour time period. All these things are made possible by simple commands, and otherwise it's very, very difficult to create these plots. That's my take for you. So in summary, use teachable transformation for converting the time series data into a R time series data structure. Then you can do all kinds of things. There are more things here. Due to time limit, I have to stop here. Okay. I told you there are subplots available for you. Okay. You can also remember you can use all the tidyverse applications here, like the dplyr transformations to do your time series analysis. Okay. There is also, I said, sub-series analysis you can do. Okay. Sub-series analysis means it takes categories, right? It takes the each of the series separately and plots that as the yearly data, right? Actually, it is a monthly. I think it is monthly data. Quarterly data. Quarterly data. It takes the quarterly data from 1990 onwards to 2010, but for various differences in the beer types. Okay, the keys that are differentiating it. Okay. So again, this is the GG season. This is GG sub-series. You can do all these things very easily. There is also autoplot. You can do that too. So my take for you is that learn teachable as a function, as a transformative package data structure that will make your time series analysis easier, visualization especially. We will see that more of ARIMA modeling and more sophisticated modeling in the following weeks. But next week, we'll talk about autocorrelation. Very, very important function, autocorrelation and moving averages next week. Thank you very much, everybody. Here is the question time. Do you have any questions? Let me see. I'm going a little bit far away, but I hope you can tolerate this. Okay, report working through the slides to review the lectures. Can we share? Yes, I had to miss, but that's okay. All right. Any questions, please? Yeah, please go ahead. It's your time. I have been talking. I usually stop in between, 30 minutes time. I stop and ask the questions. Any questions? If you don't have, okay, there's one question here. Do you guys share the slides? Can you list all the lives to install? Yeah, I did. The simple thing for you is install Tidyverse and install FPP3. Okay, or library FPP3. I mentioned that, right? These are the two most important things. Okay? I don't think. Yeah, library FPP3 and then Tidyverse. You do that. Oh, library. I don't. Let me see. You need Teachable also. Okay. So Tibble is coming in. Tibble is coming in Tidyverse. So you need Teachable also. So those are three things. Okay. Any other question? Sorry. Is the whole tutorial will be on R or will you go? This course is only in R. Okay, not in Python. I may refer something here and there about Python, but the purpose is not about really about covering it in Python. It's just reference I might make. Sometimes it's called this way in Python and so on, but it's only the purpose is only R. That's an answer to you. Is there anything else? I look forward to working through the slides that's we talked about. Is there any other question? We may have a different session. Thank you very much. Any other questions? It's question time. Couple of more minutes. All right. So we will see next week. I hope you enjoyed. You got some 2 or 3 key points here. And what is it? Just think about that. 2 or 3 key points. Thank you very much, everybody. Have a great rest of the week. Bye-bye.
Thank you, Dr. Samamurthy, for your wonderful presentation. And thank one and all on behalf of Institute of Analytics USA for your active participation and wonderful interaction to make this session as lively as possible. We look forward to meet you next week, same day, Wednesday, 19 January 2022, and at the same time on a topic in time series analysis and forecasting, a 10-week course, part 2 in advanced data science. Thank you and good day to you all once again. This is Supriya signing off for the day. Bye-bye.
Bye.